Have you ever felt like your behavior is guided by some kind of invisible set of rules? That there's a hidden logic to why you scroll, or why you procrastinate, or why you choose one thing over another? Well, guess what? There is. And today, we're going to uncover a fundamental law that governs pretty much every single move you make. Okay, so let's just dive right in with the biggest question of all. Why do we do what we do? For decades, scientists thought they had a really simple, common sense answer. But as they started to dig deeper, they stumbled upon a mystery that would completely change our understanding of behavior forever. So our story here begins with a simple idea, a foundational law of psychology that, on the surface, makes perfect sense. But it turned out to have this critical and really mysterious flaw. This is it, the law of effect, first cooked up by psychologist Edward Thorndike. And the idea is super intuitive, right? If you do something and you get a reward, you're more likely to do it again. You touch a hot stove, you get burned, you don't do that again. You post a picture, you get a bunch of likes, you post another one. Simple stuff. It seems like it should explain pretty much everything. But that's where our mystery really begins. Because when scientists put this simple law to the test, they found all these situations where it just completely fell apart. The evidence, it just didn't fit the theory. All right, let's look at our first piece of crime scene evidence. So in this experiment, pigeons were happily pecking a key over 300 times just to get a little food reward. But look what happens when the experimenters introduced a tiny, tiny work requirement, just 10 pecks. The pigeon's work rate absolutely collapses. Now why? The reward's the same. According to the good old law of effect, they should just keep on pecking. But they don't. Something else is going on here. The key to cracking this whole puzzle, it turns out, wasn't to look at a single behavior all by itself, but to see what happens when an animal has to make a choice. And this is where the story gets really clever. So instead of one key, they put two keys in the box. Key A might pay out rewards pretty often, while Key B pays out way less. Now, the pigeon is totally free to choose. It can allocate its pecks however it wants. The big question is there any kind of pattern to its choices, or is it all just random? And what they found wasn't just a pattern. It was like a law of nature, a principle so precise and so predictable it was almost hard to believe. They called it the matching law. And the discovery they made, which this graph shows off so brilliantly, is just stunning. On the bottom axis, you've got the proportion of rewards coming from one of the keys, and on the vertical axis, you have the proportion of pecks aimed at that same key. And would you look at that? The data points fall on a perfect diagonal line. It's not random, it's not messy, it is an incredibly orderly match. So here's the bottom line. If Key A is giving out 70% of all the food rewards in the box, the pigeons will direct exactly 70% of their pecks to Key A. If Key B is only providing 30% of the rewards, guess what? It gets 30% of the pecks. They aren't trying to maximize the reward. They are precisely matching their effort to the payout. And get this. This isn't just some weird pigeon thing. The matching law has been found everywhere. In rats, in humans. For behaviors from pecking keys to just standing on one side of a room. For rewards from food to direct brain stimulation. And what's amazing is, even when scientists started punishing the pecks with a little shock, as long as the punishment was equal for both keys, the pigeons still match their pecking to the rewards. It's a truly fundamental principle. Okay, so we found this beautiful, precise law for making a choice. But how does that help us solve our original mystery, the pigeon that just stopped pecking a single key? Well, that's where we find the secret ingredient that pulls this entire theory together. This really is the million-dollar question, isn't it? If matching is all about dividing your behavior between different options, what are the options when there's only one obvious thing to do? And right here is the stroke of genius from the author of our source paper, Richard Herrnstein. He realized that behavior never, ever happens in a vacuum. Even in the most boring, empty box imaginable, there is never just one option. You see, the pigeon isn't just choosing between peck the key and don't peck the key. No way. It's choosing between peck the key and, well, grooming its feathers, walking around in a circle, staring at the wall, or just taking a break. There is always the option to do everything else. And this is the secret ingredient. Herrnstein proposed that this everything else category has its own built-in background rate of reward. You can think of it as the simple pleasure of resting or the satisfaction of grooming or just the value of doing nothing at all. He called this hidden variable rho, the rate of reinforcement for all other behaviors. So, with this final piece of the puzzle in hand, Herrnstein could put together a new, much more powerful law of behavior that could finally explain everything, from complex choices to the mystery of that single abandoned key. And here it is, the quantitative law of effect. I know, it looks a bit technical, a bit mathy, but the idea behind it is beautifully simple. The rate of any behavior, that's P, is determined by its own rate of reward, R, divided by the total rewards available in the environment, that's R plus all those background rewards, RO. In other words, a behavior's strength depends on its reward relative to everything else you could be doing. And would you look at that? Remember our original problem? This new equation perfectly predicts the data from those single key experiments. Those curves on the graph aren't just lines drawn through the data points. They are the actual predictions made by that one equation. It fits perfectly. The mystery was solved. So the big takeaway here is that this one single elegant principle explains both worlds. It explains the curved line of a single behavior where the value of pecking is competing against the hidden value of res, and it also explains the straight line of choice where two visible options are competing against each other. It's one unified theory of behavior. Just incredible. So why does any of this matter for you? Well, think about RO, the rewards for everything else, in your own life. When you're in a boring context like waiting in line at the grocery store, RO is super low. The reward you get for scrolling your phone is huge by comparison, so you get sucked right in. But in a rich context, like hanging out with your best friends, RO is really high. The rewards for everything else are all around you, and it's suddenly super easy to just ignore your phone. This same logic perfectly explains why we procrastinate. The reward for finishing that huge project, R, is way off in the future. But the rewards for everything else, RO, are right here, right now. That little dopamine hit of clearing an email, the pleasure of a snack, the distraction of a quick video. To beat procrastination, you literally have to change the equation. You either have to decrease RO by removing those easy distractions, or you have to increase the immediate R for the project by breaking it down into small, rewarding steps. When you boil it all down, it comes back to this one powerful idea from Herrnstein. The strength of any one behavior is never absolute. It's always a competition, it's always measured relative to everything else you could possibly be doing. So the next time you find yourself stuck in a habit, or you're struggling to make a choice, ask yourself this. What are the obvious rewards, the R, and what are the hidden background rewards, the RO? Because once you can see the full equation, you gain the power to change it.